Structural patterns help with relationships and communication between components. They are commonly used to connect third-party modules together through a common interface. The adapter pattern is the most common structural pattern. It connects two components that are not compatible by creating a common interface between them. The key rule that distinguishes the adapter from other similar patterns: the adapter should have no logic of its own, it only allows two interfaces to connect in a new common interface. This pattern appears when you have two interfaces and one needs to be refactored, and the refactoring will change the methods. Rather than refactoring the other interface to match, you create an adapter to keep your application running. The composite pattern is used when a group of objects and a single object should be treated and accessed the same way. This is particularly useful when the complexity of handling one element versus many elements is not much different. jQuery is a classic example. It treats a selection of multiple DOM elements exactly the same way as a single element. The decorator pattern adds functionality to an object without affecting other objects of the same class. This is achieved by wrapping the object in another class and adding new methods to the wrapper. It is essentially an extension of the adapter pattern. The next step. You find a module that almost fits your needs but is missing one or two features, so instead of looking for another module, you decorate the first. This is based on prototypal inheritance, a fundamental principle of JavaScript. The facade pattern wraps a complex library in an interface that is easier to use and understand. When a library becomes very versatile with many different options, the facade creates a simpler, less versatile interface to it. A common example: you have a class that talks SMTP and need to send an email, but you'd rather have a single send method than call a complex chain of methods on the SMTP class. The proxy pattern uses an object as a proxy to access something else, another object, a file, a folder, or database information. It restricts how and when the application will access a specific resource. A REST API interface is a classic example of a proxy pattern. Behavioral patterns are characterized by identifying communication patterns between objects. They classify kinds of behavior and how objects interact with each other. The mediator pattern creates an abstraction layer, the mediator, that handles all communication between multiple classes. As your application grows and becomes more complex, the need for a mediator to reduce the complexity of class-to-class communication grows with it. Without a mediator, every class needs to know about every other class it interacts with, tight coupling. With a mediator, objects don't interact directly. They communicate through the mediator, reducing dependencies and lowering coupling. If your application is modular and different modules are loaded at runtime, the mediator becomes your internal API. The template method pattern is used by many frameworks. It defines a method that takes a set of options and compiles part of your information, leaving placeholders for modifiable parts. This is commonly used for pre-compiling UI views, leaving some placeholders like internationalization text and some code logic to be run later. This pattern is very effective when part of the template doesn't change, because the compilation from template to output happens once rather than every time. The template method is also a classic example of inversion of control. The template calls parts of your application, rather than your application calling the template. The observer pattern maintains a list of dependents, called observers, and notifies them of changes by calling a method provided by each observer. This is commonly called an event system, and it's used heavily in event-driven architectures like Node.js. The observer pattern is very effective and useful in asynchronous programming. However, it has a well-known danger: the lapsed listener problem. If an event listener is not properly deregistered, the observer keeps a strong reference to the object it observes, preventing garbage collection from disposing it. This is a memory leak. This pattern is so heavily used in Node.js that understanding it, especially its failure modes, is essential for writing performant applications.